then sorry, we cannot solve the system naturally. Minus 45, minus 27, 3 9 is 27, minus 27, minus 10. So minus 27 plus 10, so that is minus 70. Okay, so it is not 0, good. So A inverse is minus 1 upon 17. These two gets opposite, so minus 9, 3, minus 2, 5. So that is equal to minus 9 times minus 1 upon 17. So it is 9 upon 17, 2 upon 17, minus 5 upon 17, minus 3 upon 17. And B is 6, 1. So what is A inverse B? This times that, this times this, like this. You see, this is how you do it. Look at my pen. 9 upon 17 times 6. Fix the column here, fix the column. Exhaust the rows. Row by column, row by column, like this, row by column. 9 upon 17 times 6 plus 2 upon 17 times this, like that. So 9 6 54 plus 2 56, 56 upon 17, minus 30 minus 3, minus 33 upon 70. So x is equal to 56 upon 17, y equal to minus 33 over 17. Homework, you don't have to turn in homework, but we will discuss quickly tomorrow, on Tuesday. Solve the following system. Solve the systems. Solve the system of equations. So number 1, 5x minus 6y 1, x plus y is 10. 3x plus 2y is 9. 6x plus 4y is minus 10. X minus 6y is 6, minus 5x plus 4y is what? 12. So make it minus 12. Okay, that's your homework. Practice this. Next, let us go to this problem. This problem. Find A inverse if A is this. So, number 2. A is the matrix. Let's take a look. Cosine sine minus sine cosine. Cosine theta, sine theta, minus sine theta, cosine theta. How to find A inverse? Well, here you see determinant of A is cosine squared theta plus sine squared theta. Minus minus, so plus that's, but that is 1. So that makes our life easy. So A inverse of 4. A inverse will be, interchange these two. One upon determinant, but determinant is 1. So number 3, e to the plus e to the x plus e to the minus x. I see. Wait. E to the x plus e to the minus x minus e to the minus x. Okay, good. So what's the determinant? 1/4 this times this minus this times that. So e to the x e to the x plus e to the minus x squared minus e to the x minus e to the minus x squared. So that is 1/4 e to the 2x plus e to the minus 2x plus 2 e to the x times e to the minus x. That is e to the 0. E to the 0 is 1 minus e to the 2x plus, so that is minus e to the minus 2x. And this is minus 2, minus plus, plus 2. And you see the good thing is these things cancel. It's 4 upon 4, that is 1. So that's easy. So A inverse is, these two remains, these two interchange, but if they're the same, so even if they interchange, that's nothing. Nothing happens. And then these two with negative. No? Hmm? Next, suppose you take a matrix. What is the trace? You see, everything that we are doing here will be generalized to 3. Trace of A. It's called TRA. That's how it is written. It is sum of the diagonal elements. This is the main diagonal. Sum of the diagonal elements, A plus. We'll talk more about trace later. A matrix A is called symmetric if A is A transpose. A is called skew symmetric if A is negative A transpose. Now I want to also tell you yeah. A is, I will give you time to write. It's called, and I'll give you time to write. Wait. Good. Ah. Oh. Now, you see, let us go back to transpose. Actually, I told you about transpose right at the beginning. Ah, here it is. Yeah. So let us recall transpose. Okay, this is we have to let us play now with transpose. There's something much to say about transpose. So if I take a matrix A, let us write it in the Aij form, because we are going to generalize this to 3 by 3 and then to n by n. Oh, so A11, A12, A21, A22. What is A transpose? The rows become columns. First row becomes the first column. First row becomes the first column. A11, A12. Second row becomes the second column. A21, A22. Any questions, anybody?
Can you please go back to the solution of problem 1 and then you gave us today?
Problem 1. This one? Hello?
Yes, thanks. Yes, thank you.
So what's the question?
Professor, will you email us the lecture?
Yeah, of course, every day.
Okay, thank you.
So what's the question here?
I just wanted to check out my solution, so that's good.
Okay. May I proceed? Continue?
Yes, go ahead.
Thank you. So this is A transpose. Huh? So a couple of very important laws for transpose, very important. A plus B transpose, you can easily check this, is A transpose plus B transpose. A minus B transpose is A transpose minus B transpose. And let me yeah, okay. Then A transpose transpose, everybody can understand that. That is A. I'm going to give you time to write. K is a scalar, Ka transpose. K goes out, A transpose. And this is the interesting thing. AB transpose is B transpose, A transpose. You can easily check them. Easily check them. But you must know, they are true, they are valid for 3 by 3 matrices, n by n matrices, so you should be. And this is the interesting thing. See how they behave. B transpose, A transpose. Similarly, we have something like this, you see, theorem. AB inverse is B inverse A inverse. Remember, matrix multiplication is associative, not commutative. So I want to prove this. So prove, you see how it works. AB times B inverse A inverse is equal to, matrix multiplication is associative. So A times B inverse A inverse. That is A times I A inverse. That is A inverse. And that is I. B inverse A inverse AB is B inverse A inverse A, B. So that is B inverse I, B. And that is B inverse B. And that is I. Hence, AB inverse is B inverse A inverse. So these two properties are very important. Very important and useful properties. AB inverse is B inverse A inverse. That means if A and B are invertible, then their product AB is invertible. And AB inverse is B inverse A inverse. AB transpose is B transpose A transpose. Here, another point, just a minute, please. This is obvious. I should have written it, but that's so obvious that, yeah. A inverse inverse. What do you expect? That is A. Okay, finally, the last topic today, and that's most important. If A is invertible, then A transpose is also invertible. A transpose inverse is A inverse transpose. Very important, this is actually very important. Proof. Okay. Oh, so you know this. So what is I? I is 1001. What is I transpose? 1001. So I is always I transpose. Okay, let's try to prove this. A inverse is I. We know that, right? That implies take the transpose on both sides. That is I. And see how transpose behaves. AB transpose is B transpose A transpose. So that implies A transpose times A inverse transpose is I. Next, note this, call it 1. A inverse A is I. Take transpose on both sides. That implies A transpose, A inverse transpose is I. Let's call this 2. So A transpose times A inverse transpose is I. A transpose, no. No, 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 no. No, 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 yeah. This is going to be AB transpose is B transpose A transpose. So inverse transpose is A inverse transpose times A transpose. Good. Now I'm happy. Compare 1 and 2. So from 1 and 2, A transpose A inverse transpose is A inverse transpose A transpose is I. And that implies that inverse of A transpose inverse, is equal to A inverse transpose. Proof. Mhm.
I'm sorry, Professor. I have one more question.
Just a minute. I will take all questions. Wait.
Okay.
Wait a second. Wait, I will take your. I take all questions. Wait. Finally, I will prove this. What follows from here is a very interesting thing. Well, I'm going to take your question because this is the last topic. If A is an invertible symmetric matrix, okay, wait. I want to give you some homework. And then I'm going to consider to take your questions definitely. Okay, I will prove it here. Homework. Find all values of A, B, C such that A is skew symmetric, whose definition I gave you. Here is this matrix. Oh, no, I have not talked about 3 by 3. No, so can drop it. Drop it now. Drop it. Drop it. I want to give you a few more homework problems. Wait. I do remember there are some nice problems here. Where have they gone? Yeah. Oh, we will not waste time on, we will very quickly move to 3 by 3 matrices. That is on Thursday. Today is 2 by 2? No, Tuesday. Oh, don't have those problems. Anyway, first let me take your question. What's your question?
I was gonna ask you a question about the invertible matrix, but I think I found it in my notes, so never mind.
Oh, okay. Okay. Okay, first let's try to prove this. If A is an invertible symmetric matrix, then A inverse is symmetric. But this is easy, you know, because of what we just proved. We proved this, A transpose inverse is A inverse transpose. So I want to prove that A inverse is symmetric, right? So A inverse transpose is A transpose inverse. But A is symmetric. That means A is equal to A transpose, that is A inverse. And that implies A inverse is symmetry. Let me end today's lecture if I can find some good problems for you. Some more homework problems will be nice. Well, I have to talk about 3 by 3 matrices, but we're doing it later. Yeah, these are very important. Yeah, there are some. Yeah, this is good. Homework. I will give you time to copy. Wait. Find A if. This is a good problem. Number one, 7A inverse is minus 3, 7, 1, minus 2. I will give you time to copy, don't worry. Number two, because this is the last part, 5A transpose inverse is, I have to explain what this is, minus 3, minus 1, 5, 2, number 3, I is the identity matrix always, remember? Minus 1, 2, 4, 5, number 4, A inverse is 2 minus 1, 3, 5. Very good. That's where we end. Let me explain. So you see, this is good. You are given all this information. The inverse of 7A is this matrix. The inverse of 5A transpose is this matrix. I plus 2A inverse is this matrix. A inverse is this matrix. Find A. So there will be four answers. Find A if this. Find A if this. Find A if this. Find A if this. Okay, this is where I will stop today. Good place to stop. So from Tuesday onwards, September 1 onwards, this is what we will be doing. We meet at 1:40. We continue up to 2:40, then give you a 5 to 7 minutes, 10 minutes break, and then we finish the lecture at 3:30. Let us make a tentative thing here. Exam 1, October 1. And it should cover chapters 1 and 2. We will see. Should cover chapters 1 and 2. We will see that. Yeah, because I will talk about 3 by 3 matrices this Tuesday, sorry, and quickly move to determinants. Quickly move to determinants. So that is chapter 2. Finish chapter 2, then come back to chapter 1. That's the way we will do it. Okay, this is where we stop. And I'm going to send you the notes right away. And we will be doing that.
Professor?
Any questions now? Yeah.
Yeah, I have a question. Are there going to be proofs on the first exam?
Good question. Yes, there will be proofs on the first exam. There will be proofs on the second exam. There will be proofs on the final.
Thank you.
But I will let you know. I will tell you more. It will be mostly computational. Okay. Any other questions? So first thing we will discuss on Tuesday, we will go over these homework problems. They are very important problems. Take them seriously. So the one set homework I gave here, I think, don't miss them. Yes, this one set, and this one, the second set. This is a very good question. First set is mechanical. This is very interesting. This, if you can do, then that means you have understood today's topic. So today we finish 2 by 2 matrices. That's it. And Tuesday we'll be doing 3 by 3. First we will discuss these problems, and then we move quickly to determinants. Yes, what was the question?
Hi, Professor. When are you going to upload the books?
Huh? Sorry?
When are you going to give us the PDF of the book?
So you can get the PDF. PDF is available. PDF is available, but and I will, if you want, I can send you also.
That would be good. Thank you so much.
Yeah, if you want, I can send you also. But it is very much available. You can see this. So, and really, books will not be very useful, very important. What you need is to follow the class lectures carefully. That's very important. So there was a comment. There was a funny comment that he didn't teach how to solve what? Yeah. So, by the way, on Tuesday I will call out the names. So I would like to see each one of you. That's extremely important. Get your video camera correct. Go to get your video camera correct. No,
Professor?
Yes, please.
I have a question regarding about the all the materials are in chapter 1 that we just covered.
Yeah. These materials are in chapter 1. What I taught today, they were all in chapter 1. Yes.
I know. Okay, so chapter 1, but which section?
Oh, they're scattered, mainly scattered. Section 3, section 4, like that.
Okay.
So chapter 1, when I do chapter 1, I will not follow the order of the book.
All right.
I'll follow my order.
And also, are you gonna record the next class?
No, there will be no. I will not be recording. I will send the lecture notes.
Okay. And also, you mentioned about the one PDF thing, like after the final exam, or no, like there's something.
Not after the final exam. What do you mean after the final exam?
You said
I'm
one
talking about
PDF.
each. We'll talk about that when we come. Each exam, when you submit the exam, the entire exam should be in one PDF file. That's what I meant.
Oh, okay. Okay. Thank you.
Oh, but don't go so fast. I mean, I will give written instructions. Okay, so that's about it. So remember, so from Tuesday onwards, we will be following this routine. We meet exactly at 1:40, come exactly at 1:40. 1:40 to 2:40, and then maybe 7-8 minutes break, maximum 10 minutes, and then finish at 3:30. I will start with these problems, and then I talk about 3 by 3 matrices. And then later on, I will move on to chapter 2, then come back to chapter 1 and finish the rest. So that's much better, because there are lots of things in chapter 1 which are not really all interrelated. It's much better to do this way, 2 by 2, then 3 by 3, then move on. Any questions? Okay, then I'm ending the meeting, and I'm going to send you these notes. Every day I will be doing this. Okay, I'll send you the notes. Now, for the first 2 days, anybody who doesn't get the notes, please definitely let me know, because I'm following the email addresses that I find on CUNY first. Okay, so I'm ending the meeting today. Any questions?
Thank you, Professor.
Thank you. Bye.
Thank you.